overall system for this project adopts a DC-coupled architecture. PV and battery storage share a common DC bus, which is the key to achieving 0-millisecond seamless switching. During daytime solar generation, power directly feeds the load first, with surplus energy routed to storage. During grid outages or low irradiance, PV and storage co-power in instant sync, delivering 0-millisecond seamless switching to the load, with 0 perceived interruption. When battery storage runs low, the diesel generator kicks in automatically, ensuring continuous production, downtime-free. First, let's look at the two core power supply units. PV and battery storage, connected directly in parallel to a shared DC bus. This is the PV grid connection unit, with 4 units configured in total. Electricity generated from 4 distributed solar arrays is fed into these 4 cabinets, then passes through internal DC-DC modules for voltage regulation and stabilization before being delivered to the main DC bus. This is Kortrong's liquid-cooled BESS, also connected to the shared DC bus, enabling energy storage and precise on-demand discharge. Behind me is the PCS and step-up transformer container. The main transformer inside is an oil-immersed unit, adaptable to complex outdoor operating conditions, ensuring long-term, rock-solid reliability. Behind me is the ATS and bypass container, integrating a dual power transfer switch and bypass system. It ensures automatic switching between grid, generator, and BESS power. During maintenance, the bypass circuit maintains uninterrupted load supply. The system features grid-forming PCS technology, autonomously building and supporting grid voltage and frequency. It also suppresses voltage sags and harmonic distortion, significantly boosting power stability. The oil-immersed transformer handles voltage matching and galvanic isolation, unifiedly dispatching multi-source power. Working in seamless synergy, the system guarantees uninterrupted power for critical loads.